Hi, this is Liam in for Bear. A frontier model is a vast store of knowledge. Some of it heals, some of it harms. What if you could give it an off switch for the dangerous half without lobotomizing the rest? Here is the constraint. You want three things at once. Lock dangerous knowledge surgically, still let trusted users reach it for legitimate purposes, and don't dent general performance on everything else. Three goals that must hold simultaneously. Today's safety approach guards the output, refusal training, input and output classifiers. All of it sits on the exit door of the model, but the model's knowledge is still intact underneath. A determined attacker probing jailbreaks is snaking past the door, not bypassing knowledge that was removed, bypassing guards on knowledge that was merely hidden. The room is still full. The obvious alternative, filter dual-use data out of pretraining. Virology text never enters the model, but this commits you to one model with one fixed set of capabilities. Want virology on for biosecurity researchers and virology off for public deployment? You train two complete models. At frontier scale, that is prohibitively expensive. Graham gradient-routed auxiliary modules takes a different route. At every transformer layer, you attach extra neurons. These extras are grouped into modules, one per dual-use category: virology, cybersecurity, nuclear physics, niche code. 4 modules riding alongside the main model. Training has two kinds of passes. On general text, gradient flows through the whole network, everyone learns. On virology text, gradient routing kicks in. The general weights are frozen, only the virology module updates. Dangerous knowledge accumulates in its module and nowhere else. After training, delete the module. The capability disappears with it. The rest of the model is completely unchanged, or leave the module in behind an access key for trusted deployment to biosecurity researchers. One base model, multiple configurations. 4 categories, each can be on or off. One training run produces 16 deployable configurations, the full binary grid. That is the combinatorial win at the heart of Graham. 3 tests of rising realism. Test 1, synthetic children's stories, topic tagged. Graham can forget any topic on demand. Each configuration performs approximately as well as a model trained from scratch on filtered data, without the cost of retraining from scratch. Test 2, real web code and science data, 4 actual domains. Delete the module, the capability score drops, general performance stays intact. Now the adversarial question: what if an attacker fine-tunes on malicious data to restore the capability? Graham holds, filtering holds, but unlearning, where knowledge is merely suppressed, not removed, snaps right back with fine-tuning. That is the removed versus suppressed contrast that matters. Test 3, scale, 7 model sizes from 50 million to 5 billion parameters. At every size, Graham matches filtering, and the gap between module on and module off grows as the models get larger, which means the mechanism gets stronger, not weaker, as you scale. Honest caveat stated plainly: this is early preliminary research, not in any production Claude model. Testing reached only 5 billion parameters, and capability was measured by next token prediction, not real-world harm assessment. And some dual-use knowledge may be so entangled with general knowledge that no module can separate them cleanly. Take this into your next session. Liam in for Bear. An off switch for dangerous knowledge. Research AE Studio times Anthropic. Liam in for Bear.